I hope you're ready for another video about graphing sines and cosines, because it's time for math with Mr. Troy! The purpose of today's video is to talk about how the horizontal aspects, or the horizontal transformations, affect the graphs of the sine and the cosine. Now all the other graphs are going to be the same way, but it's best to get started with the simple ones. So we're going to start looking at this one, the cosine of 2x. We know that anytime that there is a coefficient multiplied by x inside the function, that's going to change the width. So this one, because it's 2x, is going to be 1/2 as wide as the parent function. Since the parent function has a period of 2 pi, we can find the period by doing 2 pi over b, which in this case is the coefficient of x, 2, which tells us that we are going to have a period of pi. So, what does that mean? I want you to think of the horizontal stretch and shrink of a trig graph like a spring. If you push on a spring, it will compress, but it won't get any shorter or taller. So as a trig graph compresses, it gets skinnier and skinnier without getting any taller. So we've decided that the only difference that this graph has from the parent function is its period. Now, this is where we have two options. We can graph it as we normally would, and that's what I'm going to do this time. The other thing that we can do is we can set up new intervals to better fit our function. And we're going to decide what to do based on, the point of what we're graphing. So for my y-axis, I'll just use 1, 2, and 3 as we did in class today, and -1, -2, and -3. Now, normally we split the graph into 4 parts so we can graph our 5 points. But since we've compressed horizontally, we're actually going to split it up into 4 smaller parts. So one period of the graph is going to go from 0 to pi as opposed to 0 to 2 pi. But it's still going to have the same major points. So the cosine is going to be high, middle, low, middle, high. It's just that that period length is going to be 1 pi, not 2 pi. Okay? Now if we fill in the points, you can see the difference. So that is one cycle of the graph. Its period is pi. The reason it's pi is because the 2x makes it half as wide. So if I graph it on the same graph I've been using, then I can graph more of it in the same amount of space. Again, this graph is very similar to the parent function, except it happens twice as frequently. The amplitude didn't change, but the frequency did. Like I said, you've got two options. You can either graph on the same graph that you've been graphing, or you can change your intervals to suit. I'm going to do that on this one. So I see that I have the sine of pi over 2x. Since I know the period is 2 pi over b, I can say that the period here is 2 pi over pi over 2. Complex fractions rear their ugly head again. So our period here is going to be 4. Not 4 pi, but just the number 4. Now remember, 2 pi really means like 6.28, so this is just slightly smaller. So the other way to do this, instead of graphing on the same graph we've always been graphing on, is to set up your graph to fit your period. So for example, for this I might do 1, 2, 3, 4, and 1, 2, 3. This is a sine function, so it's going to go middle, high, middle, low, middle. Now, there is an obvious drawback to this. The obvious drawback is that then every graph looks exactly the same. You wouldn't really know the difference between this graph and the sine parent function if I would have said, oh, this is 2 pi, pi, and pi over 2. So that's the problem with just always changing your intervals to suit, is that you can never really tell the difference between that graph and the parent function. Just something to think about as you're doing graphing problems. And the final thing we're going to talk about here is moving the graph left and right. That is called a phase shift. Now, if you've been going to our Google Meets, we've talked a bunch about this and how the sine and the cosine are related. One thing I want to remind you from the beginning of the entire year is that you need to think about what is being added or subtracted to x, not in this case to 4x. So you need to factor that away from the x, but you're not factoring it outside of the sine function. So you need to think about doing this type of factoring. So what this function means in comparison to the parent function is that it is 1/4 as wide. It's compressed, and it is shifted pi over 8 to the right. Pi over 8, which is half of pi over 4. So I'm going to set up my intervals slightly differently. Because of the changed period, I only went to pi instead of going to 2 pi. That allows me to have each one of my spaces be pi over 8, which is nice because the function is moved pi over 8 to the right from the parent function. Because the coefficient of x is 4, our period is actually going to be pi over 2. So what that means is that our graph is going to start at pi over 8, and its period is going to be pi over 2. So one cycle of the graph is going to fit inside this space. Whenever we figure that out, we're going to break our period into 4, which is convenient because this happens to already be broken into 4. And then starting at that initial point, we're just going to do our sine parent function pattern, which is middle, high, middle, low, middle. So one period of our function looks like this. I did the thing I wasn't supposed to do. I wasn't supposed to write that while I was recording the video. Silly me. Let's try again. One period of our function looks like this. I don't want to put bad graphs out into your universe, gang. So that's one period of our function. Now, a lot of times instructions will tell you, oh, graph 2 periods of your function or whatever. So in that case, you would just want to use your duplicate tool, which you all have on your keyboards, I assume, and just copy over a couple of cycles of your graph. Cool. Okay, so we can see how that differs from the parent function. Here's something to think about in terms of the parent function. The parent function has a period of 2 pi. So using the entire graph that we were given, or the entire graph grid or graph paper, we would only be able to graph one period. And you can see at least 4 on this graph. Okay, so I'm going to leave you with this challenge. Can you graph this, which puts everything all together? I hope you can. All right, thanks for watching, and have fun.